I want you to imagine, and it's not too great a stretch of the imagination these days, that the U.S. and China are in a very tense face-off in the 110-mile wide Taiwan Strait. Chinese forces are massing around the island, and this time, while the show of force might be more saber-rattling by Beijing, it could also easily be the prelude to a blockade or a full-blown invasion. To counter that threat, America and its allies urgently need swarms of unmanned systems, including air and seaborne drones, as well as other assets. But military and intelligence leaders are told there simply aren't enough of them available. Why not? Well, because key subsystems needed to create them, batteries, flight controllers, and motors, are in short supply because they're still being built in just a handful of factories in a handful of countries, one of which is now at the heart of a conflict zone. I'm painting a hypothetical scenario here, but the risk is all too real. And it's a risk that's being underlined time and again during the conflict in Ukraine, where shortages of key components for drones and other systems have impacted the Ukrainian military's ability to field them and counter Russian aggression. Now, I don't want to come across as critical of Ukraine's war efforts. On the contrary, the country's fighting forces have shown immense valor and ingenuity in the field. My point is that while drone technology existed to help the Ukrainians counter a much bigger adversary, what didn't exist, at least in some cases, was a resilient enough supply chain of key components. We're in the midst of a new era of warfare and intelligence gathering. Exquisite systems are still essential for projecting power, but we're seeing a new reality on the battlefield. Relatively cheap, commercially sourced systems are being deployed at scale, and they're morphing incredibly fast, sometimes in a matter of days or weeks, assuming enough components are available. Ukraine has become a much-studied laboratory for this new approach. To cite just one example, the Ukrainian military has successfully targeted Russian warships with relatively inexpensive drone boats in the Black Sea, impacting Russia's more sophisticated naval capabilities. And Russia was dealt another major blow by Ukraine's Operation Spiderweb, a coordinated UAV campaign that penetrated deep inside Russia and destroyed long-range bombers. Spiderweb used more than 100 low-cost drones, launching covertly from inside Russian territory, to successfully strike 5 air bases and destroy or disable over 40 aircraft. The bad news is that it's not just the good guys who are using this tech. Aggressors are too. Houthi rebels have repeatedly disrupted shipping in the Red Sea with relatively inexpensive air and sea drones capable of overwhelming naval defense systems. This shows how readily available technologies can level the playing field, allowing the smaller actors to inflict significant damage and potentially alter the course of conflicts in ways not previously possible. Today, I'm going to explore what this sea change in the national security landscape means for the Defense Industrial Base, also known as the DIB. And I'm going to do this by talking about another DIB, which is my shorthand for design, iterate, build. Given the changes I've described earlier, it's vital that we take a fresh look at how we do all of the things in the realm of national security. Gone are the days when we could afford to rely on bespoke systems produced by traditional players to deter our adversaries. If we are going to prevail in future conflicts and other security challenges, we're going to have to redesign our design processes, greatly accelerate our ability to iterate all kinds of strategic systems, and develop the capacity to build those systems cheaply, rapidly, and at immense scale. Let's start by talking about design. Traditionally, systems have been created for performance, not for resilience, and that has driven businesses to optimize specifications. The result is that America is producing lots of highly engineered and rigid products for our military and our intelligence community that lack interoperability. These systems work on paper, and they have the performance edge needed to get the better of adversaries' systems. But they run into hurdle after hurdle when used in dynamic and ever-changing operating environments, as we've seen in Ukraine. So what needs to change when it comes to the design process? First and foremost, we need to adopt design for agility as our guiding principle. What I mean by this is that we have to think about the need to be able to scale production fast, right from the start of a system's creation, not just how to optimize its performance. We also have to create more modularity and redundancy in system design. By using modular and interchangeable parts, we can simplify design processes and create more agile, flexible supply chains. Let me give you an example. IQT Portco Anduril has developed Lattice, an open software platform that is component agnostic and can be used to rapidly design and produce systems for different industries and applications. Next, we need to design for speed, accelerating the entire design process from A to Z. This is all the more essential when planning for environments in which systems are likely to be modified frequently. Artificial intelligence can be a powerful force multiplier here, both for existing product developers and, crucially, for new entrants looking to develop systems without decades of existing processes and methodologies to draw on. Using AI to augment designs cuts the time to design and shortens the feedback loop, boosting efficiency between digital versioning and physical realization of designs. At IQT, we're investing in companies exploring the art of the possible here. For example, NTAP sells software incorporating AI that accelerates the creation of design and optimizes these for production. Using AI as an accelerant in this way will become more effective as more data related to physical machines and processes is generated and collected. Last but not least, we must design for security. All too often, businesses focus on the performance and cost of a physical system, leaving security as an afterthought, if it's thought of at all. Swarms of autonomous vehicles can't protect Taiwan if they're vulnerable to a cyber attack, perhaps because of malware hidden in them as part of a vulnerability China exploited in a chip years ago, well before it was integrated into the vessel's system. IQT Portco Security is building verification tools to identify vulnerabilities in hardware components and firmware. So just to briefly recap here, redesigning design, in our view, means designing for agility, which is planning early for scaling as well as embracing greater modularity and interchangeability. Designing for speed, meaning accelerating time to design through the use of AI and other tools. And designing for security, that is, adopting a proactive mindset that puts security on par with other key considerations from the outset of the design process. I want to emphasize the importance of these three elements, not just because they'll help us jumpstart legacy design processes and mitigate supply chain risks, but also because I believe they'll spark even more innovation from dynamic startups. These keys to the redesigning the design process also tie directly into the second part of my DIB architecture, accelerating the iteration of systems. One of the early lessons learned from the conflict in Ukraine was the need to iterate very fast on systems being deployed. When a drone or other asset is in the field long enough for an opponent to create a countermeasure to it, it can be rendered useless overnight unless it can be swapped out entirely or adapted to counter the countermeasure. We've seen this deadly cat-and-mouse game on repeat in Ukraine, as one side seeks to outsmart the other's advances on the battlefield. When the Ukrainians began using cheap drones with great effect on Russian targets, the Russians upped their game in terms of electronic countermeasures. In response, the Ukrainians hardened their drones and began using fly-by-wire systems that kept a physical connection to the operators. This kind of rapid iteration is going to be vital for the future. Instead of thinking of systems being finished and battlefield ready, we must build in fast feedback loops. These loops need to take data about how systems perform in the field and use the insights to help create new iterations of them in days or weeks for redeployment. What's fielded on day one is likely to look very different by day 10 and very different again by day 20. At IQT, we're investing in startups helping to reduce the time to new designs. Our German Portco quantum systems can push out firmware updates to the frontline UAVs in Ukraine on a frequent cadence. The company's strategy was inspired by soldiers who came to it and asked for more frequent software updates based on their feedback from the field. Another compelling example is our Portco Neuros, whose founders are former drone pilots. They've drawn on their flying experience to develop a drone whose design is frequently updated on inputs about its battlefield performance. This approach has helped Neuros get its drones to market fast and to ensure it stays ahead of adversary countermeasures. So more generally, for rapid iteration strategies to be successful, companies need to access to testing environments that reflect operational ones as closely as possible, while still recognizing data from the field is the very best way to validate a system's true effectiveness. They also need a frictionless way to share lessons across the ecosystem. And finally, to be effective, iteration needs to work in lockstep with interoperability. It's no good swapping components if this means a newly modified system can't work in harmony with others because of the changes made to it. That's where a company such as Iterate is essential. Iterate provides an integrated software package that ensures continued interoperability between strike, recon, long-range strike, and sea vessels, as well as drone launches from those vessels. Its technology is already being deployed in Ukraine, and its multi-domain solution could be relevant in future Taiwan scenarios too. Okay, we've covered design and iteration, but what about the third element in my DIB framework? B, for building at scale. The advantages we can gain from the first two pillars won't amount to much if we can't rapidly increase production of systems to counter scaled threats from our adversaries. In our 2024 Advanced Manufacturing blog series, I talked about the importance of revitalizing America's industrial base and highlighted some key issues related to this. One of these is the need to prioritize the creation of more agile and distributed domestic manufacturing capacity through enablers like advanced manufacturing technology and AI-driven optimization. Another focus is that we badly need more innovators focused on developing the next generation materials to bolster advanced manufacturing in the U.S. We simply can't remain dependent on supplies of key materials that could be choked off at the whim of our adversaries. We also can't afford to lose focus on developing the highly skilled workers who will drive future manufacturing innovation. Now, true to the spirit of DIB, I'm going to rapidly iterate on those points as I zero in on the specific challenge of building at scale. This challenge has become so significant that at IQT, we review a company's ability to scale production as part of our decision criteria for hardware investments. In particular, we look closely at a startup's component supply chain. Often, critical parts of a system come from a single supplier, and that means there is considerable uncertainty about the startup's ability to scale output. IQT Portcos have had first-hand experience of this. Drone company Skydio, for instance, was sanctioned by China in 2024, impacting its ability to produce because it was no longer able to buy some critical components. So this brings me back full circle to my point about designing for agility. By making systems more modular and interchangeable, sourcing risks can be mitigated. Another way to deal with it is to look for opportunities to vertically integrate key elements of the supply chain. Anduril is making headlines with its massive Arsenal One manufacturing facility in Ohio, where the entire production process, from raw materials to finished autonomous systems, will be produced within a single software-driven factory. Anduril is aiming to redefine the scale at which autonomous systems can be produced to support the U.S. and its allies with cutting-edge capabilities. And it's also looking to develop skilled workers who can help deliver these capabilities. AI has an important role to play here too. Our UK Portco Cloud NC has developed a software platform that helps engineers and machinists bridge the gap between a digital design and what it takes to physically make a part. The company aims to cut the time down by 80% by taking a part design file and data about a business's machining tools and then using AI to develop the code needed to actually produce the parts. In Portco, Havoc AI is building autonomy subsystems that can be deployed across distributed platforms, enabling swarming capabilities across domains. Okay, I've taken you through the thinking behind our DIB architecture. But before I wrap up, there's another letter I want to add to the acronym, and that's S for source. Sourcing the raw materials we need to make systems is fundamental to our strategic success. And in recent years, we've seen the U.S. take concrete steps to address access to these critical resources. At IQT, sourcing technologies that can help us address these issues has been front and center in our strategy. Through our Compass Investing initiative, we've been aggressively identifying and investing in tech that can provide the U.S. with ownership and optionality around the crucial material supply chains required for manufacturing. A good example is our Compass investment in Alta Resources, which is developing a biological platform for the extraction and separation of critical minerals from electronic waste and mining ore. These minerals are essential for electronics production, and Alta's low-cost, environmentally sound processing platform will provide a U.S.-based alternative to a supply chain controlled by China. Encompass Portco Novion Magnetics is the only commercially ready rare earth element magnet manufacturer owned and operated in the U.S. Novion can use mined and recycled materials to produce magnets that are critical for hardware systems at prices that are competitive with large-scale foreign manufacturers. And even beyond our Compass efforts, IQT is looking at alternative approaches for sourcing inputs. We are very excited indeed to support these and other innovative companies looking to provide the U.S. with more sources of supply to feed future demand. Now, strictly speaking, the S for source should come at the start of my DIB acronym, but you can't design and build stuff if you don't have the raw materials to do so. But you may be familiar with the term DIBS. It's used to signal that someone is going to be the first to something. To give some examples from my household, dibs on the last piece of sushi, dibs on the comfy couch for movie night. To finish my remarks today, I'm going to argue that the global security investing community and the innovative companies that are essential to the national security of the United States also need to embrace DIBS to ensure our war fighters and intelligence operatives get the capabilities they need when they need them. We have to be the first to redesign design, leading through agility, speed, and security. We have to be the first and the fastest at leading iteration of key systems so that our adversaries struggle to catch up. We have to be the first when it comes to building highly effective systems at scale. And we have to be the first to develop and field revolutionary technologies that reshape critical supply chains. Will achieving all of this be easy? Absolutely not. But it's essential if we're going to respond effectively to the kind of scenario around Taiwan that I outlined at the start. We're fortunate in this great nation and in its allies to have the most innovative, the most ambitious, and the most determined entrepreneurs and business builders. And we're fortunate to have the most dedicated government partners who come to work every day to advance their crucial missions through the use of innovative technology. Together, we can do this. Together, we must do this. And together, we will do this.